So here in this problem, we need to determine the coordinate of the third vertex of an isosceles triangle if the other two vertices have coordinates 2, 5 and 2, 0 with the equal signs having length of 3 units. So let's try to understand the problem graphically first. Let us suppose we have a triangle A, B and C. We name the coordinate of B as 2, 5 and let the coordinate of C be 2, 0 and the coordinate of the third vertex, let it be x, y. Now, it's given here that this is an isosceles triangle with the equal sides have a length of 3 units. So let's first begin by finding out the length of side BC because the coordinates of the endpoint are known. Because we can easily apply the distance formula which states that if we know the two endpoints and then the distance between them can be obtained by the distance formula which is simply given by square root of x2 minus x1 whole squared, which is the difference of the x coordinate squared added to y2 minus y1, which is the difference of the y coordinate, and then square it. So we can apply the distance formula to find out the length BC. The BC is going to be, so let's take the difference of the x coordinate, so that's simply 2 minus 2 whole squared added to the difference of the y coordinate 5 minus 0 squared. So this will be equals to, so 2 minus 2, that's simply 0. We have 0 squared added to 5 squared, so that gives us a value 5. So that means length of BC is going to be 5. But it is given here that the equal sides have a length of 3 units. That means the side AB is going to be equals to the length of side AC. So both are going to have a length of 3 units. So let's apply the distance formula to both AB and AC, and we are going to use the fact that given that AB equals to AC, that's given to us. Fine. And both of them have a length of 3 units. Well, we'll only use this to equation AB equals to AC. Now, what's the value of AB? AB is simply, all we have to do is take the x coordinate and from it subtract the x coordinate of B. So that means we have x minus 2. We're going to square it and then add it to the difference of the y coordinate. So that's going to be take the y coordinate of A, which is y, and the y coordinate of B, that's 5. So we have y minus 5 whole square. So this is going to be the length of AB that we have obtained by using the distance formula. Similarly, we can obtain the length AC. So that's going to be given by x minus 2 whole squared added to y minus 0 squared. So what we'll do, we'll take the square on both sides. This is going to get rid of the square root. So we have x minus 2 whole squared plus y minus 5 whole squared, that will be equals to x minus 2 whole squared plus y squared. Now we can cancel out x minus 2 whole squared from both sides. So we have y minus 5 whole squared equals to y squared. So let's take the square root on both sides. So we get y minus 5 equals to plus or minus y. Now we can only consider y minus 5 equals to negative y. So y minus 5 cannot be equals to positive y because that equation is not going to hold true. So that gives us the value of 2y. So 2y will be equals to 5. Solving for y, we get 5 over 2. So now that we have the value of y, we need to find out the value of x. For that, again, we'll be using the fact that AB equals to 3 units. So let's find out the value of AB. So AB will be equals to square root of, we've already obtained this value, that's simply x minus 2 whole squared plus y minus 5 whole squared. And this length is equals to 3 units. Now squaring both sides, we get x minus 2 whole squared plus y minus 5 whole squared, and this will be equals to 9. So let's keep x minus 2 whole squared as it is. Now in place of y, we're going to replace it with 5 over 2. So 5 over 2 minus 5 whole squared equals to 9. X minus 2 whole squared plus, so 5 over 2 minus 5, that's going to be negative 5 over 2 whole squared equals to 9. So x minus 2 whole squared plus 25 over 4 equals to 9. So we have x minus 2 whole squared equals to 9 minus 25 over 4. So that's going to give us the value 11 over 4. Let's take the square root on both sides. We get x minus 2 equals to plus or minus square root of 11 divided by 2. Or we have x equals to 2 plus or minus square root of 11 over 2. So we have obtained the values So when x equals to 2 plus square root of 11 over 2, we have one value of y, so that's 5 over 2. And we have when x equals to 2 minus square root of 11 over 2, then y corresponds to 5 over 2. So these are the possible vertices. The one vertex will be 2 plus square root of 11 over 2, comma 5 over 2. Or the other vertices could be 2 minus square root of 11 over 2, comma 5 over 2.